As we leave the wonders of our solar system behind, let's place it within a grander context, the Milky Way galaxy. We know many things about this vast cosmic structure. Unlike what some might think, our solar system is not located in the center of the Milky Way, but nestled in one of its four spiral arms, the Orion arm. This arm, along with our entire solar system, orbits the center of the Milky Way at an incredible speed of 828,000 kilometers per hour. Yet even at this breakneck speed, it takes a staggering 230 million years to complete just one orbit around our galaxy. The Milky Way itself is a colossal structure, containing between 100 to 400 billion stars, with each star potentially hosting its own planets. Our solar system was formed about 4.5 billion years ago, but there is still much we do not understand about the cosmos around us. Questions such as the exact size and limits of our solar system, the full extent of the sun's gravitational influence, and the mysteries of the Kuiper Belt remain unanswered. Why does our solar system appear divided into two distinct regions, with terrestrial planets on one side and gaseous giants on the other? These questions fuel our curiosity and drive our quest for knowledge. Dear traveler, today we embark on a journey through our galactic neighborhood, attempting to unravel the well-guarded secrets of our solar system. During this space odyssey, we will explore the planets from the Sun to the Kuiper Belt, encountering Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and even Pluto, the ninth planet that is no longer classified as a planet. Are you ready to discover the latest research and observations about our solar system and better understand the universe around us? Let's take off towards the Sun and begin our exploration. As we venture deeper into our cosmic neighborhood, we turn our gaze to the star that sustains life on Earth, the Sun. ESA's Elite Solar Orbiter, launched in February 2020, is at the forefront of uncovering the Sun's many mysteries. This ambitious mission aims to provide answers to questions that have puzzled scientists for decades. The Sun, a seemingly unchanging beacon in our sky, holds secrets that challenge our understanding. In November 2023, a groundbreaking study revealed that the Sun might be smaller than previously thought. The methods used to measure the Sun's size have evolved since the 1970s, initially relying on total solar eclipses. 2 decades later, experts refined these measurements using the Sun's oscillations caused by its waves. Measurements from the 1990s indicated that the Sun was 0.05% smaller than earlier estimates. Recent data suggests that the Sun is even smaller by a fraction of a percentage point compared to those 1990s measurements. While this might seem like a minor detail, even the smallest fraction of a percentage is crucial in understanding the Sun's internal structure. These subtle changes can have significant implications for our models of stellar evolution and solar physics. As we move away from the Sun, we begin our exploration of the solar system, starting with the closest planet to our star, Mercury. Orbiting at a distance of 0.4 astronomical units from the Sun, Mercury is not the hottest planet despite its proximity. That title belongs to Venus, whose dense atmosphere creates a powerful greenhouse effect. Mercury's surface temperatures vary dramatically, ranging from -180 degrees Celsius at night to 430 degrees Celsius during the day. Despite its extreme conditions, Mercury offers a wealth of scientific intrigue. It has almost no atmosphere, causing sunlight to be 7 times more intense than on Earth. If you stood on Mercury, the Sun would appear 3 times larger than from our home planet. Mercury is the smallest planet in our solar system, with a mass nearly 20 times less than Earth, and it orbits the Sun in just 88 days at a speed of 47 kilometers per second. Mercury's core, composed of iron and nickel, is particularly imposing, making up 85% of the planet's radius and more than 40% of its volume. This gives Mercury the distinction of being the second densest planet in the solar system after Earth. Remarkably, Mercury is one of only 2 terrestrial planets, along with Earth, that has a magnetic field. The surface of Mercury is a tapestry of craters and scarps, reminiscent of the Moon's dark side. Without an atmosphere to shield it from asteroids, its surface bears the scars of countless impacts. Yet there are also large, smooth expanses, possibly the result of ancient lava flows. Only 2 probes have visited Mercury so far. Between 1974 and 1975, Mariner 10 captured 2,700 photos of Mercury, mapping 45% of its surface. The Messenger spacecraft, which flew by Mercury 3 times before entering its orbit in 2011, mapped up to 90% of the planet, collecting 277,000 photos and creating a 3D model of its magnetosphere. Currently, the Bepi-Colombo mission, a joint venture between ESA and the Japan Aerospace Exploration Agency, is en route to Mercury. Launched on October 19, 2018, this mission aims to place 2 probes in orbit around Mercury by the end of 2025. The mission is one of ESA's most challenging due to Mercury's extreme temperatures and the immense energy required to reach its orbit. On June 27, 2022, Bepi-Colombo delivered impressive images of Mercury from a distance of 800 kilometers, revealing a surface strikingly similar to the Moon's. As we await the arrival of these probes into Mercury's orbit, scientists continue to make significant discoveries. A study published in October 2023 revealed that Mercury is still shrinking. Despite its high surface temperatures, Mercury's crust is a poor thermal conductor, reflecting most of the sun's rays. This causes its massive core to cool progressively, leading to the planet's gradual contraction. The Messenger probe had already shown that Mercury had shrunk by at least 14 kilometers in diameter over the last 3 billion years. Recent signs of the planet's continued contraction further our understanding of its dynamic nature. As we continue our journey through the solar system, Mercury stands as a testament to the complexity and wonder of our cosmic neighborhood. Stay tuned as we delve deeper into the mysteries of our neighboring planets. We leave behind the enigmatic Mercury and set our sights on its neighboring planet, Venus. Often called Earth's twin due to its similar size and composition, Venus reveals a much darker side. Despite these similarities, Venus is a true hellish world. The planet's dense atmosphere, rich in clouds of carbon dioxide and sulfuric acid, traps the sun's heat, creating an intense greenhouse effect. This results in average surface temperatures of a scorching 462 degrees Celsius, making Venus the hottest terrestrial planet in the solar system. The pressure on its surface is crushing, about 92 times that of Earth, equivalent to the pressure found 900 meters underwater on our planet. Venus's thick clouds and violent weather patterns add to its infernal nature. Winds can reach speeds of up to 700 kilometers per hour, far surpassing the most powerful hurricanes on Earth. These winds whip around the planet, creating a dynamic and ever-changing environment. Despite its current inhospitable conditions, scientists speculate that Venus may have once harbored oceans and potentially even life. Evidence suggests that an uncontrolled greenhouse effect led to its extreme transformation. The discovery of volcanic activity on Venus, confirmed by radar images from NASA's Magellan probe in the early 90s, adds another layer to our understanding. These images reveal a crater that changes shape, expands, and overflows with molten rock, providing compelling evidence of active volcanism. In November 2023, the scientific community was abuzz with another groundbreaking discovery: atomic oxygen in Venus's atmosphere. Detected at 17 points on both the day and night sides of the planet, around 100 kilometers in altitude, this finding offers new insights into the atmospheric processes of Venus. Unlike molecular oxygen O2 that we breathe on Earth, atomic oxygen O1 consists of individual oxygen atoms. It is formed through photodissociation, where sunlight breaks down carbon dioxide molecules into atomic oxygen and carbon monoxide. This process sheds light on the chemical dynamics at play in Venus's atmosphere. As we delve deeper into the mysteries of Venus, scientists are gearing up for at least 3 dedicated space missions to the planet in the next decade. These missions aim to uncover more about Venus's past, its volcanic activity, and the reasons behind its drastic divergence from Earth. Venus, with its turbulent atmosphere and scorching temperatures, stands as a testament to the volatile and unpredictable nature of planetary evolution. As we continue our exploration, we are reminded that even our closest planetary neighbors hold secrets that challenge our understanding of the universe. Stay tuned as we journey further into the solar system, unraveling the mysteries of our neighboring planets. Leave behind the scorching infernos of Venus. Our journey brings us to a place that is both familiar and extraordinary: Earth, our home. Just over 41 million kilometers from Venus, Earth occupies a unique position in the solar system known as the habitable zone. This is the sweet spot where conditions are just right for liquid water to exist, a key ingredient for life as we know it. The Earth is bathed in the sun's energy, receiving about 1,000 watts per square meter. This energy sustains a delicate balance, allowing our planet to thrive with vast oceans, lush forests, and diverse ecosystems. Unlike our neighboring planets, Earth is teeming with life, from the smallest microorganisms to the largest mammals. Orbiting the Sun at an average distance of about 150 million kilometers, the Earth completes one full revolution in 365.25 days. This journey around the Sun is marked by seasons, a result of the Earth's axial tilt. As Earth rotates on its axis every 23 hours and 56 minutes, this tilt creates the cycles of summer and winter, autumn and spring. One of Earth's most remarkable features is its satellite, the Moon. Formed shortly after the Earth, the Moon plays a crucial role in our planet's stability. Its gravitational interaction with Earth creates the tides and helps stabilize our axial tilt, contributing to a stable climate over geological timescales. The Earth is the densest planet in the solar system, and its surface is a mosaic of continents and oceans. 71% of our planet is covered in water, a vital component for sustaining life. The presence of liquid water, combined with Earth's dynamic atmosphere and plate tectonics, makes our planet a flexible and adaptable world. Throughout an Earth year, the distance between our planet and the Sun varies due to the elliptical nature of our orbit. On January 3, 2024, Earth will be at perihelion, its closest approach to the Sun, at about 147 million kilometers. Conversely, on July 5, 2024, Earth will reach aphelion, its farthest distance from the Sun, at 152 million kilometers. Despite this variation, it is the axial tilt, not the distance, that determines our seasons. Recent studies suggest that Earth may not be as unique as we once thought. Life could potentially arise on other planets under the right conditions. The concept of the habitable zone is more complex than we believed, influenced by factors such as the size and energy output of the star, the atmosphere of the planets, and even geological processes like plate tectonics. As we marvel at our blue marble, we are reminded of the delicate balance that sustains life here. Earth is a testament to the intricate interplay of cosmic forces that create a world where life can flourish. Our exploration continues, and next we set our sights on Mars, the red planet, to uncover its secrets and its potential past as a habitable world. Stay tuned as we venture further into the cosmos, unraveling the mysteries of our neighboring planets and beyond. Our vibrant blue marble behind, our journey takes us to a world that has captivated human imagination for centuries: Mars, the red planet. Mars, named after the Roman god of war, is a planet of contrasts, with towering volcanoes, deep canyons, and a surface covered in iron oxide, giving it that characteristic red hue. These deposits were similar to those observed on Earth during recent volcanic eruptions. This means that a million years ago, significant volcanic activity could have occurred. While Mars is currently a cold and arid world, it wasn't always this way. Geological events such as minor landslides, earthquakes, and geysers in the polar regions still occur, reminding us of the planet's dynamic past. Since the 19th century, scientists have been searching for traces of life on Mars. The first Mars exploration mission by flyby dates back to 1965 with NASA's Mariner 4 probe. Since then, our knowledge of Mars has progressed enormously. We now know that the red planet does not host any multicellular life forms, but there could be single-celled life forms somewhere in the bowels of Mars. This is why scientists continue to search for traces of microorganisms on the red planet. But that is not all. The latest studies on Mars also aim to better understand its geological development. On May 4, 2022, NASA's InSight probe recorded the strongest earthquake ever detected on Mars or any other planet other than Earth. This magnitude 4.7 quake lasting over 6 hours was an unexpected discovery given that Mars lacks tectonic plate movements. Initially, scientists thought it could have been caused by a meteorite, but no evidence of a collision was found. This suggests the quake was caused by internal activity, shedding light on the magma currents and geological processes that have shaped Mars over billions of years. A few months later, in October 2022, NASA discovered a gigantic meteorite impact crater on Mars, measuring 150 meters in diameter and several meters deep. This is the largest meteorite impact crater ever discovered on a planet. To cause such an impact, a meteorite about 12 meters in diameter and weighing between 250 and 650 tons would have struck Mars at a speed of 7.5 kilometers per second. This impact, dated December 24, 2021, caused a magnitude 4 earthquake, revealing chunks of ice from below the Martian surface, a clue to the presence of underground liquid water. On February 8, 2023, NASA announced the best evidence to date for the existence of lakes on Mars. This announcement surprised many, as the red planet is known for its arid, dry environment with atmospheric pressure so low that liquid water cannot persist. However, Mars wasn't always so sterile. Shortly after its formation, around 4.5 billion years ago, Mars looked very similar to Earth, with a denser atmosphere and warmer temperatures. Hundreds of millions of years ago, liquid water even carved canyons on Mars. In February 2023, NASA's Curiosity rover discovered traces of waves on rocks on the planet's surface, preserved through the eons. These wavy rocks offer a glimpse into Mars' watery past. Months later, on August 9, 2023, a study published in the journal Nature revealed possible traces of life on Mars. Fossil evidence of a cyclical climate with wet and dry seasons, much like Earth. This regular and cyclical climate could have provided an environment conducive to the organization of simple organic molecules into complex organic compounds, in other words, an environment conducive to life. Mars contains many mysteries, and as we continue our exploration of the solar system, we turn our sights to the fifth planet from the Sun, Jupiter. On our way, we will navigate through the Asteroid Belt, a region formed around 4.6 billion years ago, at the same time as the solar system. This belt is filled with hundreds of thousands of small bodies, celestial objects that are neither planets nor satellites, remnants of our solar system's formation. Stay with us as we delve deeper into the cosmos, unraveling the secrets of our planetary neighbors and beyond. As we bid farewell to Mars and its enigmatic surface, our journey takes us through a region that holds the remnants of our solar system's chaotic past, the Asteroid Belt. Nestled between Mars and Jupiter, this celestial highway is teeming with countless rocky fragments, each with a story to tell. The asteroids that make up the asteroid belt vary enormously in size. From tiny specks of dust to colossal bodies hundreds of kilometers in diameter, these ancient rocks are the building blocks that never quite formed a planet. Among these small bodies, there is only one dwarf planet, Ceres, with a diameter of 950 kilometers. Ceres alone represents almost a third of the mass of the asteroid belt, yet it is a small dwarf planet. It has 14 times less mass than Pluto and is the only spherical object in the asteroid belt. The other objects have irregular shapes. Ceres, with its rocky core and mantle of water ice, shares a structure similar to that of the terrestrial planets of our solar system. Discovered as early as 1801, it has intrigued scientists for many reasons. First, it is believed to be a protoplanet, a clue to the formation and evolution of the planets. Secondly, Ceres could have housed an ocean of liquid water. The Dawn probe, launched by NASA in 2007, put into orbit around Ceres in 2015, detected complex organic molecules in 2017. The origin of these hydrocarbon compounds remains a topic of debate. Recently, new analyses suggest that these compounds could be endogenous, formed in Ceres due to the presence of water. This raises the fascinating possibility of organic deposits in the heart of this dwarf planet. Another intriguing resident of the asteroid belt is 16 Psyche, one of its most massive asteroids. Measuring 226 kilometers wide, Psyche is believed to contain a core of iron, nickel, and gold, making it a potential remnant of a primitive planetesimal, a metallic core of a dead planet. The Psyche mission, launched in October 2023, aims to unlock the secrets of this metallic world. The space probe will take 6 years to arrive at 16 Psyche, with exploration set to begin in August 2029. The mission will map the asteroid and study its properties, offering a unique window into the composition of planetary cores, including that of Earth. As we navigate through this cosmic debris field, we resume our journey toward the gas giants. Beyond the asteroid belt, 779 million kilometers from the Sun, lies the largest planet in our solar system, Jupiter. This colossal gas giant, with a radius 11 times greater than Earth and a mass 318 times larger, dwarfs all other planets combined. Visible to the naked eye from Earth, Jupiter has been known since prehistory, shining as the fourth brightest object in our night sky. Jupiter's composition is akin to that of the Sun, primarily hydrogen and helium. Its dense atmosphere blurs the lines between its surface and the gaseous envelope. While scientists speculate about a possible small rocky core, definitive proof remains elusive. Jupiter's rapid rotation, completing a full revolution in under 10 hours, flattens its poles and bulges its equator. A year on Jupiter is equivalent to nearly 12 Earth years. Jupiter, with its 95 moons and faint rings, forms the Jovian system. These moons, drawn by Jupiter's immense gravitational force, each have stories of their own. In February 2023, astronomers searching for a ninth planet inadvertently discovered 12 new Jovian moons. These small moons, ranging from 1.5 to 5 kilometers in diameter, add to the complexity of Jupiter's influence, which extends even to the Trojan asteroids sharing its orbit. Join us as we continue our voyage through the solar system, uncovering the mysteries of our planetary neighbors and the cosmic wonders that lie beyond. Navigate through this cosmic debris field, we resume our journey toward the gas giants. Beyond the asteroid belt, 779 million kilometers from the Sun, lies the largest planet in our solar system, Jupiter. This colossal gas giant, with a radius 11 times greater than Earth and a mass 318 times larger, dwarfs all other planets combined. Visible to the naked eye from Earth, Jupiter has been known since prehistory, shining as the fourth brightest object in our night sky. Jupiter's composition is akin to that of the Sun, primarily hydrogen and helium. Its dense atmosphere blurs the lines between its surface and the gaseous envelope. While scientists speculate about a possible small rocky core, definitive proof remains elusive. Jupiter's rapid rotation, completing a full revolution in under 10 hours, flattens its poles and bulges its equator. A year on Jupiter is equivalent to nearly 12 Earth years. Jupiter, with its 95 moons and faint rings, forms the Jovian system. These moons, drawn by Jupiter's immense gravitational force, each have stories of their own. In February 2023, astronomers searching for a ninth planet inadvertently discovered 12 new Jovian moons. These small moons, ranging from 1.5 to 5 kilometers in diameter, add to the complexity of Jupiter's influence, which extends even to the Trojan asteroids sharing its orbit. Because powerful telescopes with a sufficiently wide field of view are needed to capture the immense Jovian system, Jupiter found itself in the crosshairs of the telescopes of scientists whose mission was to find the ninth planet. Thanks to the high-performance tools used by scientists, only 4 images were needed to cover the entire Jovian system. The first signs of these new moons were detected in March 2021, but it took some time to confirm their existence. Of these 12 moons, 9 are retrograde, which means they orbit the Sun in a direction opposite to the Earth and most other planets and asteroids. This suggests these moons are small pieces of lunar debris resulting from collisions that destroyed larger moons and were captured by Jupiter's impressive gravitational force. Jupiter's moons are a prime object for researchers who are interested in them in the hope of finding traces of life. On April 14, 2023, the JUICE probe took off toward Jupiter. The Jupiter Icy Moons Explorer, or JUICE, aims to explore the icy moons of Jupiter. It will enter the Jovian system in 2031 to fly over the moons Callisto, Ganymede, and Europa, before remaining in orbit around Ganymede, the largest satellite of Jupiter. In September 2023, significant discoveries were made on Europa, the smallest of the 4 Galilean moons. The James Webb Telescope found traces of carbon dioxide on the surface of the moon, supporting the hypothesis that Europa contains an underground ocean of water, likely salty and about 100 kilometers deep. If the CO2 detected on Europa's surface indeed comes from this ocean, then Europa could join Saturn's moon Enceladus as one of the most habitable places in the solar system. James Webb made another important discovery in October 2023. Their images revealed a never-before-seen feature in Jupiter's atmosphere, a high-speed jet stream extending more than 4,800 kilometers above the main cloud decks north of Jupiter's equator. Until now, this feature had always been seen as a nebulous haze in Jupiter's atmosphere, but the incredible precision of the James Webb Telescope has allowed us to see it with greater clarity. This discovery is one more step toward understanding the interactions between the layers of Jupiter's atmosphere. Let's continue our journey through the solar system. Now we approach Jupiter's neighbor, Saturn. Saturn is the second largest planet in the solar system, known above all for its magnificent rings that have an average thickness of 10 meters, but can reach up to 100 meters in some places. Scientists believe that Saturn did not always have these rings of ice and dust. It is possible they were created when one of Saturn's first moons collided with the young planet about 100 million years ago. As we delve deeper into the mysteries of Saturn, we uncover the secrets of its many moons and the future of its iconic rings. We now approach the majestic Saturn, the second largest planet in our solar system. Known for its breathtaking rings, Saturn is a wonder to behold. These rings, made of ice and dust, have an average thickness of 10 meters, but can reach up to 100 meters in certain areas. Scientists speculate that Saturn's rings may have formed from the remnants of a moon that collided with the planet around 100 million years ago. Recent observations have revealed curious spots on Saturn's rings known as ring rays. These mobile and seasonal spots were first observed by the Voyager 1 probe in 1981 and later by the Cassini probe. Researchers believe that interactions between the solar wind and Saturn's magnetic field could be causing powerful electrostatic forces, lifting dust and ice above the rings. The number and contrast of these ring rays vary with Saturn's seasons, each lasting 7 years. As Saturn approaches its equinox, these ring rays become more frequent and darker, but their exact origin remains a mystery. In a rare cosmic phenomenon, Saturn's rings will soon be hidden from view for 7 years due to the planet's orbital movement. On August 27, 2024, Saturn will reach its brightest point and largest size. By March 2025, the gradual tilt of Saturn will obscure its rings from our view. On February 7, 2024, another groundbreaking discovery was published in the journal Nature. Mimas, the smallest of Saturn's 7 main moons, joined the ranks of habitable moons alongside Titan, Enceladus, Europa, and Ganymede. It is believed that Mimas has an ocean 72 kilometers deep beneath an icy crust 24 kilometers thick. This ocean likely formed less than 25 million years ago, making it relatively young from an astronomical perspective. Although life has not had enough time to develop, the presence of this ocean opens new possibilities for future exploration. Our journey now takes us to the 7th planet from the Sun, Uranus. The 3rd largest planet in the solar system, Uranus is 4 times larger than Earth and is known for its extreme cold. Along with its neighbor Neptune, Uranus is classified as an ice giant. Its atmosphere, composed mainly of hydrogen, helium, methane, and ammonia, gives it a stunning blue-green color. One of Uranus's unique features is its axial tilt of 98 degrees, causing it to present the same pole to the Sun for 42 years. Uranus has 13 dark rings made of rock and dust and 27 known moons. The 5 largest moons, Titania, Oberon, Umbriel, Ariel, and Miranda, have piqued researchers' interest. While these moons do not have underground oceans like those of Saturn and Jupiter, recent studies suggest that some of them, especially Titania and Oberon, might harbor dense and hot oceans beneath their surfaces. In 2023, the James Webb Telescope captured a remarkable image of Uranus, showing the icy giant surrounded by several moons and 11 of its 13 dust rings. Further exploration of Uranus and its moons may reveal more about these enigmatic celestial bodies and their potential for habitability. As we leave Saturn behind, we set our sights on Uranus, eager to uncover more secrets of our vast and wondrous solar system. As we bid farewell to Saturn, our journey now takes us to the 7th planet from the Sun, Uranus, a world of extreme conditions and peculiar characteristics. This ice giant is 4 times larger than Earth and is known for its stunning blue-green color, a result of its methane-rich atmosphere. In 2007, with the help of the James Webb Space Telescope, we gained essential insights into Uranus's seasons. The planet's extreme axial tilt of 98 degrees causes it to present the same pole to the Sun for 42 years, resulting in extreme seasonal variations. For instance, at the poles, days and nights can last for years. The mysterious polar cap of Uranus disappears in summer, when it is in full sunlight, and reappears in autumn as the pole plunges into darkness. The telescope also revealed 2 bright clouds that could be storms. In December 2023, another image of Uranus provided more detailed observations. This new image allowed us to see the white inner cap and the dark band at the bottom of the polar cap, along with several storms near its southern edge. On May 23, 2023, new images of Uranus were published, combining data from 2015, 2021, and 2022. This period allowed astronomers to observe Uranus's poles correctly for the first time in nearly a century. The ice giant takes 84 years to complete one orbit around the Sun. Using the Very Large Array Telescope, astronomers studied the polar atmosphere of Uranus under the spectrum of radio waves and detected a polar cyclone. This discovery confirmed that all the planets in the solar system, except Mercury, share a common characteristic: vortices at their poles. NASA has made Uranus one of its priorities, launching an observation program called the Uranus Orbiter, which will last until 2032. We are now 4.5 billion kilometers from the Sun, approaching Neptune, the second ice giant and the planet furthest from the Sun. Sometimes it is even further away than the dwarf planet Pluto. The only spacecraft that visited Neptune, Voyager 2, took about 12 years to arrive. It is the fourth largest and third most massive planet in the solar system, 17 times larger than Earth, and the densest giant planet. Neptune was discovered by deduction and not by direct observation, unlike the other planets in the solar system. It was observed for the first time in 1846, based on the calculations of astronomers. Neptune takes about 165 Earth years to orbit the Sun, with one day lasting about 16 hours and each season lasting 40 years. Neptune has a solid core of nickel and iron silicates, equivalent to the size of Earth. This core is surrounded by a hot fluid formed by frozen materials such as water, methane, and ammonia. Neptune lacks a solid surface, and its atmosphere is mainly composed of hydrogen and helium, with traces of methane. It is the windiest planet in the solar system, with winds reaching speeds of up to 21 kilometers per s. The Great Black Spot on Neptune has intrigued scientists for a long time. This enormous storm in the southern hemisphere of the planet was first sighted during the Voyager 2 flyby in 1989, with winds reaching unprecedented speeds. In 1994, another similar spot disappeared, only to reappear in 2016 in the northern hemisphere of Neptune. In September 2022, the James Webb Telescope captured an unprecedented photo of Neptune, showing not only its thin rings, but also some of its moons. In this image, Neptune flashes with a blinding brilliance, like a faceted ball. The planet shines brightest at higher latitudes and at the poles, which scientists believe are active regions that reflect more sunlight. A larger view released by the James Webb Telescope shows Triton, Neptune's largest moon, shining even brighter than Neptune itself. Triton appears star-like in the image, reflecting about 70% of the sunlight due to its nitrogen ice cover. We can see a total of 7 moons of Neptune's 14 known satellites, including Triton, Galatea, Naiad, Thalassa, Despina, and others. As we leave Uranus and head towards Neptune, we continue our quest to uncover the secrets of our vast and wondrous solar system. Uranus and head towards Neptune, we continue our quest to uncover the secrets of our vast and wondrous solar system. Neptune, the second ice giant and the planet furthest from the Sun, sometimes even further away than the dwarf planet Pluto, holds many mysteries. The only spacecraft that visited Neptune, Voyager 2, took about 12 years to arrive. It is the fourth largest and third most massive planet in the solar system, 17 times larger than Earth, and the densest giant planet. Unlike other planets in our solar system, Neptune was discovered by deduction and not by direct observation. In 1846, based on the calculations of astronomers, Neptune was first observed. It takes about 165 Earth years to orbit the Sun, with one day lasting about 16 hours and each season extending for 40 years. Neptune has a solid core of nickel and iron silicates, equivalent to the size of Earth. This core is surrounded by a hot fluid formed by frozen materials such as water, methane, and ammonia. Lacking a solid surface, Neptune's atmosphere is mainly composed of hydrogen and helium, with traces of methane. Known as the windiest planet in the solar system, its winds can reach speeds of up to 21 kilometers per second. The Great Dark Spot on Neptune has intrigued scientists for a long time. This enormous storm in the southern hemisphere was first sighted during the Voyager 2 flyby in 1989, with winds reaching unprecedented speeds. In 1994, another similar spot disappeared, only to reappear in 2016 in the northern hemisphere of Neptune. In September 2022, the James Webb Telescope captured an unprecedented photo of Neptune, showing not only its thin rings, but also some of its moons. In this image, Neptune flashes with a blinding brilliance, like a faceted ball. The planet shines brightest at higher latitudes and at the poles, which scientists believe are active regions that reflect more sunlight. A larger view released by the James Webb Telescope shows Triton, Neptune's largest moon, shining even brighter than Neptune itself. Triton appears star-like in the image, reflecting about 70% of the sunlight due to its nitrogen ice cover. We can see a total of 7 moons of Neptune's 14 known satellites, including Triton, Galatea, Naiad, Thalassa, Despina, and others. Despite the clarity of these recent images, the colors are not very bright since the image was taken in the infrared. We usually say that Neptune is dark blue and Uranus light blue, but recent images and researchers' analyses reveal that the two ice giants are actually the same color, a light shade of blue-green. During the time of Voyager 2 and the first images of Neptune, scientists had increased the contrast to better distinguish the clouds and winds in the images. In other words, Neptune had been artificially made much bluer than it was in reality. This misconception persisted until January 2024, when researchers from the University of Oxford re-established the truth by publishing photos of the two planets in their true colors. Another mystery that hangs over the two frozen giants is the possibility of diamond rains. Since the early 1980s, it has been thought that diamond hearts could exist inside Uranus or Neptune. These diamond cores would form under the action of the enormous pressures that act on the carbon detected in their atmospheres. More recently, studies have suggested that diamond showers could appear at lower temperatures and pressures than previously thought. So there could well be diamond showers on Neptune and Uranus in shallow layers of their atmospheres. We have now completed our exploration of the planets of the solar system, but our adventure does not end here. We still have some objects to explore and some mysteries to reveal. Let's take a closer look at Pluto, the dwarf planet that continues to intrigue researchers with its chaotic orbit and unique characteristics. Leave Neptune behind, our journey takes us to the outermost reaches of our solar system. Here, we encounter Pluto, the dwarf planet that has fascinated astronomers and the public alike with its unique characteristics and chaotic orbit. Once considered the 9th planet, Pluto still holds many secrets waiting to be uncovered. In October 2023, a surprising discovery was made on Pluto, a small volcano that erupts with ice instead of lava. This ice volcano, comparable in size to Cyprus, has likely erupted multiple times, producing enough ice to bury a city the size of Los Angeles. The New Horizons probe, launched by NASA in 2015, provided critical data for this discovery when it flew within 11,000 kilometers of Pluto in July 2015. Among the findings was the crater Kilat, stretching 44 kilometers long, possibly formed by landslides caused by these icy eruptions. This crater is believed to be several million years old, indicating intense seismic activity and a diverse geological landscape on Pluto. Pluto's surface is a tapestry of icy plains, towering mountain ranges, and even a heart-shaped glacial region spanning 2,000 kilometers. But Pluto's mysteries don't end there. Beyond its orbit lies the Kuiper Belt, a ring-shaped region teeming with nearly 100,000 icy bodies larger than 100 kilometers in diameter and countless comets. The Kuiper Belt is 20 times wider and between 20 and 200 times more massive than the Asteroid Belt, composed of remnants from the solar system's formation. The first Kuiper Belt object, KBO, discovered was named QB1, found in 1992. Studying the Kuiper Belt is crucial as it holds clues about the early solar system and is believed to be the source of short-period comets, acting as a reservoir similar to the Oort cloud for long-period comets. The New Horizons probe continued its mission, flying over the Kuiper Belt in 2019, and in May 2023, scientists presented data suggesting the possible existence of a second Kuiper Belt. However, this remains a hypothesis, and further research is needed to confirm it. In September 2023, Japanese astrophysicists proposed another tantalizing possibility, a planet larger than the dwarf planets within the Kuiper Belt. This hypothetical planet has not been directly observed but inferred from the highly inclined orbits of certain objects, suggesting the gravitational influence of a larger body. If it exists, this planet could be 1.5 to 3 times the mass of Earth, with an inclined orbit taking it 250 to 500 astronomical units from the Sun. Beyond the Kuiper Belt lies the hypothetical Oort cloud, a vast region extending up to a light-year from the Sun. Though never observed, this cloud is believed to house long-period comets and marks the outermost boundary of our solar system. The debate over the limits of our solar system is ongoing, with some defining it by the heliopause, where the solar wind gives way to interstellar space. As we conclude our journey through the solar system, we realize that the edge of our planetary neighborhood is not a fixed boundary, but a fluctuating concept shaped by ongoing discoveries and evolving theories. The mysteries of the Kuiper Belt, the Oort cloud and the potential hidden planets beyond remind us that our exploration has only just begun. It's time to look beyond its boundaries and ponder the vastness of space. In 2013, Voyager 1 crossed the heliopause, the region where the solar wind is stopped by the interstellar medium, marking humanity's first incursion into interstellar space. Yet, this definition is primarily based on the influence of the sun's electromagnetic field, not its gravity. Another perspective, supported by many astronomers, considers the gravitational influence of the sun. From this viewpoint, the limits of our solar system extend to the outer edge of the Oort cloud. To grasp the immensity of our solar system, imagine it on a reduced scale where the sun is represented by a yellow ball just 1 centimeter in diameter instead of its real 1.4 million kilometers. In this miniature perspective, Earth, which is 109 times smaller than the sun, would be an almost imperceptible 0.1 mm grain of sand located 1 meter from our miniature star. This distance corresponds to 150 million kilometers in space, or 1 astronomical unit. On this scale, Jupiter would be 5 meters from the sun, Neptune at 30 meters, and Pluto would float about 40 meters away, with the Kuiper Belt extending between 30 and 55 meters from our miniature star. However, even at this scale, we would not have yet reached the very edge of the solar system. The Oort cloud would mark the outer limit, extending up to about 100 kilometers from our miniature sun. To put things in perspective, Alpha Centauri, the closest star to our solar system, would be 400 kilometers away in this scale model. Our journey through the solar system reveals its complexity, yet it is far from unique in the immensity of our universe. The solar system is one of countless systems, each made up of a star with planets in orbit. To date, astronomers have discovered more than 3,200 stars with planets in orbit, and this is just the beginning. So, while the solar system is not unique, we might wonder if its configuration is unusual. Among the many planetary systems studied, there's a great variety of possible structures. At the moment, we have not found another system quite like ours, with dense, rocky planets closer to the star and gas giants further away. Could our solar system be an exception? Perhaps. Scientists believe that the arrangement of the planets in our solar system is due to chance, a happy coincidence for us. As we continue to explore the cosmos, we will uncover more about the uniqueness and commonality of our solar system. The journey has just begun,